This video introduces polar coordinates. Now, you will already be familiar with the polar form of a complex number. It uses the modulus argument idea. Let's have a look at the diagram here. We have what we call the pole, and we have an initial line, which is the horizontal line where the positive x-axis would be if we were thinking about a set of coordinate axes. All we have when we have polar axes are the pole and the initial line. Positive direction is anti-clockwise from the initial line. The negative direction is clockwise from the initial line. Polar coordinates are described by the distance from the pole, so r, equivalent to the modulus, and also by the angle from the initial line, theta. So we have a coordinate r theta rather than an xy coordinate. In the syllabus that you're working with, you only ever have positive r, and we will look at that in detail in class. For the purpose of this video, what we're going to be looking at is converting between polar equations and Cartesian equations. In order to be able to do that, we base our working on the right angled triangle that we've got here. And you can see from the right angled triangle that my x coordinate is equivalent to r cos theta, and my y coordinate equivalent to r sin theta by using your trig. R we can find by considering Pythagoras, r squared equals x squared plus y squared, and theta we can find again by using our trig and applying arctan. So it's these four equations that I'm going to work with now in order to be able to convert from polar to Cartesian and vice versa. What you will see from the equations is that sometimes a polar equation can be far more simple than a Cartesian equation, and that means that they have applications within things like radar and also music technology. Right. Let's have a look at question 1 in your notes. As you can see, we've got three polar equations. They're always r equals something. And we're going to use the equations that we have at the top of the page to help us convert to Cartesian, and then that will help us understand what the equation looks like. So let's consider A. We have r equals 3. We'll come on and look at what that might be in more detail, but to convert, I want to be able to use this equation. So I'm going to square both sides of my equation. That's going to give me r squared equals 9. I can now replace r squared with x squared plus y squared equals 9. And I recognise that that's a circle sent to the origin with a radius of 3. So r equals 9 is a very simple way of describing a circle with a radius of 3 in polar coordinates. B. Then we've got r equals 2 plus cos of 2 theta. Now, I need to be able to replace the r, and I need to be able to replace cos of 2 theta. And I need to be able to do it using these equations at the top of the page. So to begin with, I'm going to think about this here. I haven't got an equation for cos of 2 theta. I'm going to have to convert it into something that just contains cos theta or sin theta. So I'm going to use my double angle formulae. So I'm going to use the version for 2 cos theta. I'm going to go for the cos version. So I'm replacing cos 2 theta with 2 cos squared theta minus 1. That gives me 1 plus 2 cos squared theta. So I've now got a cos theta and an r, both of which I need to replace. Two ways I can do it. We'll do it by replacing cos squared theta with x divided by r, and that's squared. And that's r equals. Now, I'm going to tidy this up so that I get deal with the denominator here. So that's going to give me an r squared on the bottom. So I'm multiplying everything through by r squared. So that's going to give me r cubed equals r squared plus 2 times x squared. So I've eliminated the cos. Now I've just got to deal with the r's. Now r cubed, I'm going to be using the r squared equals x squared plus y squared equation. So I need x squared plus y squared. Now I want r cubed. So I know that that's r squared, so I need to square root that, and then I need to cube it. So that's going to give me a 3/2 as my power. R squared I can replace directly with x squared plus y squared, and I have a plus 2x squared. And I could simplify that further by combining the x squared terms. But that's converted to Cartesian, and as you can see, that's quite a complicated equation compared to the polar one that I started with. There are other ways of approaching it algebraically, but that gives you one version. Now let's have a look at C. We have r equals 8 cos theta plus 6 sine theta. Now, this time I'm going to take a slightly different approach, which I could have taken with part B. What I'm going to do here is I'm going to multiply through by r. That's going to give me r squared equals 8r cos theta plus 6r sine theta. Why have I done that? Because I've now got an r squared that I can replace easily, and I've also got r cos theta and r sine theta, both of which I can replace easily. So r squared is x squared plus y squared, and r cos theta I can replace with x, and r sine theta I can replace with y. If I follow this through algebraically, I have x squared minus 8x plus y squared minus 6y equals 0. Completing the square, x minus 4 squared minus 16 plus y minus 3 all squared minus 9 equals 0. X minus 4 squared plus y minus 3 squared equals 5 squared. And so I have a circle, centre at 4, 3 with a radius of 5. I can now recognise the type of equation that I have. So that's going from polar to Cartesian, and as you saw, I used 3 equations. I used the x equation, the y equation, and the r squared equation. Right, we're now going to go back the other way. So let's have a look at question 2 at the bottom of the page. So y squared equals 4x. I'm replacing with my xy equations. So, nope, that's y squared. So I have r squared sine squared theta equals 4r cos theta. I am aiming to generate an equation that has r equals, so that it's in polar form. So I can divide through by r and also the sine squared, actually. So let's go to 4 cos theta over sine squared theta. So thinking about splitting this into two trig functions, I get 4 times cot theta cosec theta. And that's the polar equation for A. B. X plus y squared equals 5. Not yet in a form I can deal with. I need to expand my bracket. So we have x squared plus y squared plus 2xy equals 5. Written in that order so that I can directly replace this with r squared. And this term here is 2. And we've got r cos theta and r sine theta. So I've got r squared cos theta sine theta equals 5. Need to see if I can tidy that up. Is there an identity I can use? Yes, there is. This is my double angle. So I have r squared plus r squared sine of 2 theta equals 5. R squared equals 5 divided by 1 plus sine 2 theta, having factorised my left-hand side. It would be standard practice to leave it as r squared rather than to go to r with the square root. You will often see polar equations with r squared at the start or r. Okay, let's have a think about C. So what do we got? Y root 3 equals x plus 4. So replacing y with r sine theta, root 3. I'm going to replace x with r cos theta. Now, what we're going to do is we're going to get r on its own, and we're also going to combine the trig terms so that I can simplify. So we have root 3 sine theta minus cos theta. I'll make that equal to 4. Now, I want to be able to simplify this. I am going to use my addition formulae. I can already see I've got a root 3. I'm going to think about some of my standard trig values. And what I'm actually going to do is I'm going to divide the bracket through by 2. So I'm going to have a 2r outside. Balance things up. So we're dividing that by 2. Minus a half here, cos theta equals 4. Now, I can start to recognise these as standard trig functions. So I have 2, and I have root 3 over 2 is cos of pi over 6. So I have sine theta cos pi over 6. And I have cos theta pi over 6 for the half equals 4, and that allows me to reverse my addition formulae and gives me our sine of theta minus pi over 6 equals, and it's going to be a 2 because I'm going to cancel the 2 and the 4 as well. So there we have the equation. One more line of working so that we have r equals. It's going to be 2. I'm dividing by sine, so that's cosec, and it's theta minus pi over 6. So the principle behind that one was to replace x and y with the appropriate polar form, and then I'm just working with trig equations. So that's your introduction to polar equations and converting between polar and Cartesian.